So to get the acceleration, differentiate with respect to time again. Okay, so what we'll get, that implies r double dot, that is the first differentiation, this is the double differentiation, fine, with respect to time, is equal to differentiation of this. Keep this in mind, applying chain rule. Okay, keep this in mind, chain rule. First on this very thing, because these all are functions of time. Okay, differentiating it, we will get double differentiation of r, that the magnitude of the position vector, double differentiation into r hat, plus r dot, keeping this as it is, into the differentiation of this. We'll get again same problem here. We have to substitute back this very thing. Keep this in mind. Okay, so we'll get r hat dot plus, these are the three terms now, so we have to apply chain rule 3 times sum. Okay, so that means r dot theta dot, differentiating first theta hat, plus keeping first as it is, or differentiating second one, that is theta double dot with respect to time, theta hat, then plus or theta dot, differentiating now third term, r hat double, r hat dot. This is the chain rule for this very thing. Okay, so here we are getting two problems in the same equation. This very thing with respect to time, we are differentiating again the unit vector, and here we are again differentiating unit vector with respect to time, so we have to convert it into something else. And for this very term, we know that r hat dot is equal to this, we have calculated already. So I will get r double dot will be equal to r double dot r prime, this is the vector, plus r dot and r hat dot, what is that equal to? This very thing, dot, sorry, r hat, substituting this very thing, fine, I'm substituting this r hat dot equal to theta dot theta hat, plus r dot theta hat, plus r theta dot double dot theta hat, plus r theta dot theta hat dot. Now there is a problem again. We are again differentiating with respect to time this unit vector, so we have to convert this very thing into another. What is the equation we are getting? R double differentiation, that is the acceleration, R double dot R prime plus, sorry, R hat plus R dot theta prime plus R dot theta prime plus R theta double dot theta hat, then plus R theta dot theta hat dot. But we know, I have told you earlier, that theta hat is equal to minus time, which gives the position vector. This gives the unit vector. This is the unit vector of theta, I can say. Okay, this will give the unit vector along the position of the theta. So theta, sine of theta, plus along the y-axis, that's along the x-axis, plus cosine of theta j hat. Fine, this is the, I have told you earlier that this is equal to this very thing. Now we have to differentiate this very thing with respect to time, so that means theta hat dot with respect to time, differentiate sine, differentiation of sine is cosine, but again then differentiate theta, that is theta dot, sine differentiation is cosine theta into theta dot I, plus cosine of theta differentiation is minus, so we'll get minus sine of theta dot along j. Fine, theta dot and theta dot, keep these in outside, so we'll get theta hat dot is equal to, will be equal to minus and minus, keep this is all, this also in outside the brackets, cosine of theta dot outside, plus, now plus because minus is outside, sine of theta j and theta dot, which is outside of both of these terms. Now cosine of theta plus sine of theta, I have already told you this is the unit vector along the radial axis. Okay, so that means theta is minus times r hat, that is the unit vector, again unit vector along the radial unit vector. I can see a radial unit vector. Fine, this very thing is radial unit vector. It's already shown to you in the earlier case. Fine, so r hat multiplied by theta dot is fine, minus times this very thing. So we will get theta dot prime is equal to minus times this very thing. So substitute this very thing here. What we'll get? This very thing will be replaced and will be equal to r theta dot minus times r dot or r hat theta dot. Fine, substituting this very thing here. So what we'll get ultimately, the double differentiation of position vector r will be equal to r double dot r hat. This very thing are same, plus times, so we'll get 2 times r dot theta hat plus r theta double dot theta hat minus, because this is minus inside the brackets and minus plus is outside, so plus minus, it is minus here, or theta into theta it's theta squared, theta dot square rather, theta dot square, and along the vector radial vector unit. Okay, unit vector odd hat. So this will give the acceleration along the circular path in the polar coordinate system. We can furthermore recycle it, like we can write it down r component, keep these together, r dot minus r theta dot square position vector unit vector r. Fine, and it is theta hat, keep these together, plus times 2 r theta dot plus r theta double dot theta hat. This will give the acceleration of a particle moving along circular path but in polar coordinate system, plane polar coordinate system here, because we haven't considered the 3D. It's polar plane coordinate system. So this will give the acceleration in the polar plane coordinate system. Again, we can consider if the particle is moving along the circular path with a constant velocity, that is theta dot is constant. If theta dot is constant, that is the uniform velocity, uniform motion. That is the magnitude of the velocity is kept constant, angular velocity I'm saying. But that doesn't mean there isn't an acceleration, because there will be still acceleration, only double dot of theta will be 0. That means this term will vanish here, this term will vanish because it contains theta double dot and nothing else. Fine, that means there will be still this very term, and this very term, and that will produce the acceleration. That will be the centripetal acceleration again. So that means even though the motion is uniform, acceleration will be still produced inside the body, and that will be the centric and produced by the centripetal force. So this is the centric force. Fine. So that means you have to keep in constant whether it is the Cartesian coordinate system or the polar coordinate system, even though the theta dot is constant, that is the uniform motion, but still then the acceleration is produced inside the body if it's moving along the circular path, and that very force which causes the acceleration inside this body is the centripetal force, and the acceleration produced by that force is given by this very thing. So this is the acceleration of a particle along the circular path in polar coordinate system. So you will come across these concepts at many places in physics, because rotation is a broader concept and broader topic and is widely used in the modern physics as well. So you have to be very much cautious about these very things, how to differentiate all these things. This is how to calculate acceleration and velocities, revision all these things again. If you don't get on the first attempt, try to rewind this very lecture again. So I think you should cope it and get it right away, okay? So furthermore, if you have any queries about this very topic or the earlier one, please feel free to comment in the comment section. I will be dealing with all those misconceptions generated, or the queries which you post there. I will come across those very questions. I will try my level best to answer those if it is possible in the written form, or if I feel that it is not convincible there to post it in the text form. So furthermore, for that very thing, I will record another lecture if it is needed. Fine. So feel free to comment in the comment section. I'll see you in the next.